Our next speaker is going to be Jen Greenwood. She's the LCS SBIR manager, and although PEO LCS is known for the Littoral Combat Ship, they do mine hunting, they do underwater unmanned vehicles, they do all the mission modules that go on and off of the LCS platform. So it's a lot more dynamic than meets the eye with just the Littoral Combat Ship. So I'm sure they'll have some interesting topics. Jen?
Good morning, my name is Jennifer Greenwood. As Mac mentioned, I'm from PEO Littoral Combat Ships. As he also said, we are kind of a jack of all trades, so we have 5 topics that kind of run a wide gamut of different mission-related areas. So our first one is the automatic acoustic detection and identification for USV situational awareness. So for this, the ideal solution will increase the situational awareness and provide safer navigation for unmanned vehicles. This is kind of a new area for us. Unmanned is getting to be one of our primary focus areas as far as unmanned surface vessels and unmanned underwater vessels. So the ideal solution will detect and characterize typical maritime sounds to avoid collisions and various problems that can occur when we get into a cluttered environment. It will identify the direction and general location, and also in the near term they want it to notify an operator, somebody who's going to be monitoring the unmanned vessel as it navigates. However, in the far term they want it to alert an onboard autonomy system. So we're looking at going to an autonomous fleet. We want to make sure that whatever capability or solution is developed out of this topic will also develop into that autonomous fleet. So our next topic is N171047. It is for advanced mine hunting sonar data. And this we would like a solution that'll increase and enhance the effectiveness of Navy mine hunting in with high-frequency sonar systems by fusing sonar data to reduce the false alarm classification rate. The solution will do a fusion of acoustic data from side scan and volume search sonars, and also will do a post-mission analysis, visualization algorithms to process the sensor data and display contacts to operators. So moving on to our next topic, which is N171037, improved magazine armor for ballistic performance. We're looking for an innovative mechanical surface treatment. There have been a lot of SBIRs in the past that have leveraged different composite materials for ballistic protection and those kind of things. However, LCS is restricted by weight limits. And so a lot of those composites and different metallic alloys and different things that we've used in the past are far too heavy. I know there's been several studies done. We're specifically looking for a treatment, something that's going to not weigh us down or go over weight structures, something that's going to keep us in the same weight allowance that we've been kind of given. So any surface treatments that will kind of free up weight allowance would be the ideal solution here. So our next topic is N171062, the 3D image from sensor fusion. This is specifically a software solution that we're looking for. We're looking for one that will construct a 3D model of the target from the available sonar or image data that's available. One of the issues that we have is that the imagery is usually two-dimensional and does not provide an accurate target picture. Sometimes there's more there than what we can see from the image. So we're looking for something that will basically construct a model within 2 minutes of the image and the data coming in, and that will fuse available image and sonar data and also update as new information is available. So as the sensor comes around an object, it can feed that imagery in and also update and construct the model. And our last topic is an STTR topic. It is N17A-T013. It is a low-cost magnetic sensor for mine neutralization, identification, and charge placement. This will utilize a low-cost magnetic or electromagnetic sensor to provide additional identification capability for mine neutralizers, specifically in murky water. We've been having a lot of good luck in clear water with high bandwidth, but we're looking for something that's going to perform in murky water or very limited bandwidth, because as technology becomes more capable, we're looking for underwater modems and different sensors that can communicate, and those will only work in a very low bandwidth environment. And this, again, is an STTR, so it does require that 30% of a university or a federal-funded research program participation. And that's all we have. Thank you.